New Rubber Technologies, or NRT, has proprietary technical capabilities and an operational platform that allows it to process rubber and plastic waste to produce usable polymer materials and molded products. While rubber recycling, processing, and manufacturing are all industrial processes, significant materials science and chemistry capability are required to engineer materials and products with specified properties. NRT has a full laboratory of staff and chemists capable of further materials research, specific material and product development, as well as comprehensive quality control testing. Post-consumer waste rubber, principally end-of-life tires, are first granulated or purchased in granulated form, commonly referred to as rubber crumb. No formal collection infrastructure exists for post-industrial rubber waste recycling, and as such, NRT engages directly with specific rubber product manufacturers to collect and recycle those streams. Tires and other rubber products are cured to have the uncommon juxtaposition of strength and flexibility characterized by rubber products. That curing process is called vulcanization, which means it is cured and is a solid. Without this original curing process, rubber does not have the everyday utility conceived of by consumers. That said, this vulcanization makes rubber waste difficult to use as a virgin rubber replacement, and as a result, half of all end-of-life tires in North America and Europe are burned as fuel annually, and the vast majority of post-industrial rubber waste is either landfilled or burned. NRT has a patented rubber de-vulcanization process which largely reverses this curing process and transforms the granulated rubber crumb into a chemically reactive polymer capable of reincorporation into rubber and thermoplastic elastomer compounds and products as either a partial or total virgin rubber replacement. NRT's de-vulcanization process is a dry chemical-mechanical process conducted at ambient temperature. Specified weights of rubber waste and the chemical catalysts are blended in a low-intensity mixer before being conveyed to the high-shear mechanical portion of NRT's line. The chemical additives are approved by the U.S. Food and Drug Administration as food and medicine ingredients. The result is an environmentally safe process with very low electrical energy requirements, which in turn equates to low costs of conversion. The resulting devulcanized rubber particulate, or DRP, is less dense than its crumb predecessor and a core ingredient for both rubber and thermoplastic elastomer compounds as a partial or complete virgin polymer substitute. Rubber product manufacturers mold with what is called rubber compound. The rubber manufacturing process can be thought of as analogous to baking bread. In NRT's process, the devulcanized rubber particulate are akin to reactive breadcrumbs, which are then blended with other compounds or dough in a high-intensity mixer. Other ingredients may include some polymer content, reinforcing agents like carbon black, as well as processing aids, extenders, and cure. The high-shear mixer drops the rubber compound or dough for conveyance to a drop mill, which, like a common kitchen rolling pin, both completes the mixing process and sheets the material so that it can be put into a mold and into an oven for curing. Depending on the sheet's required thickness, it may either continue down the compound line or be sheeted more precisely on a calendar mill, as is the case here. The sheets can be cut and stacked, or as is the case with this compound, rolled with plastic separator sheets ready for sale or to be moved to the next stage of the process. NRT offers rubber compounds formulated for customers' specified needs. Rubber compounds are most typically compression molded or extruded into rubber products. Compression molding presses, as shown here, use heat and pressure to trigger the cure in the rubber compound to once again vulcanize the rubber into a manufactured product. Using the bread-making comparison, the cure is analogous to yeast in a dough, and in either case is used to make and form the final molded product. NRT is typically molding as an outsourced manufacturer on behalf of its customers who own the brand and ultimate sales channel for these products. In this first case, the top layer is a green-colored compound derived from a specifically chosen industrial waste with requisite UV resistance qualities, which in turn is laid on top of a tire-derived black compound to produce an anti-erosion mat. Two mats are cured simultaneously in this single press. The part edges are then trimmed by its operators and placed into a die cutter to ensure the drainage holes in the mat are also well trimmed. In this second case, a single compound derived from tire waste is molded into professional gymnasium tiles. Physical properties include a specified hardness to absorb and deflect weights in gymnasiums. Another component of NRT's capability allows for a secondary use of the devulcanized rubber, namely as an ingredient for the manufacture of what are called Thermoplastic Elastomers, or TPEs. NRT uses this development and small batch production line to blend DRP derived from varying waste rubber sources with specific and varying plastics to target applications as diverse as flexible PVC replacement and asphalt modification. This process uses very specific operating conditions to intimately mix the materials and allow for chemical reactions at the molecular level. This is an alternate way to make what otherwise is a material category more typically made in petrochemical plants today. TPEs, like plastics, can be sheet extruded, blow molded, or as is the case here, pelletized for incorporation into downstream injection molding processes. NRT is planning on installing significant TPE compounding capacity of its own in 2019, but in the interim, NRT's TPE formulations are currently available to customers via third-party compounder fulfillment. Pelletized eco-TPEs are also used by NRT to injection mold varied products. Unlike the compression molding process, which takes material from room temperature and heats it as part of the curing process, injection molding preheats the pellets into liquid form and subsequently injects into a cooled mold such that it reforms into a solid material. TPEs are not typically cured, which allows molding times to be significantly less than those required for vulcanization. In spite of this manufacturing advantage, TPEs are not suitable for many applications addressed by vulcanized rubber, most notably pneumatic tires. In this press, NRT molds interlocking tiles with various consumer, commercial, and industrial applications. NRT's downstream molding operations provide it the opportunity to both constantly improve its materials processing capabilities for the benefit of its customers and to offer its molding infrastructure as an outsourced manufacturing resource to its customers. NRT's materials and molding capabilities provide its customers with numerous benefits: specified technical or functional performance, cost savings and predictable pricing, weight savings, and the opportunity to leverage socially and environmentally conscious branding. So too, NRT offers rubber manufacturers the opportunity to divert waste from landfill and incineration. That can be accomplished by the incorporation of that waste by NRT into alternate materials or products, or via a closed-loop recycling capability offered as a service, in which case NRT processes and returns that waste to its manufacturing source for reincorporation into that original application or alternate application by that same rubber enterprise. In any of these forms, NRT's technical and operational team stand ready to assist you with your waste diversion or polymer material or molded product engineering and fulfillment needs.